There are two applications for the design of hydraulic materials and structures. Let's take a recap from the application of the Bernoulli's principle in relation to pipes. As fluid moves from a wider pipe to a narrower one, the volume of the fluid that moves in a given distance in a given time period does not change. But since the width of the narrower pipe is smaller, the fluid must move faster, that is, with greater pressure, in order to move the same amount of fluid with the same distance in the same amount of time. So for its first application, sewage conduits. Take for example in your toilet, and there are narrow pipes below that toilet bowl connected to the sewage area. When flushing, there is a mechanism inside the toilet pumping pressure so that the water will then come out to flush any contents inside. And then, it will go through the pipes with a high speed until it reaches the septic tank. In this scenario, Bernoulli's principle is applied when pressure is used to increase the speed of flushing and the speed of the contents flushed to move through the pipes. Fast flushing is needed especially for public restrooms so that the waste will then be cleared out instantly in the toilet bowl and then be clean ready for the next person. The number of curves in the pipe system also affects the continuity of flow of the flushed contents. It has been determined that the curves involved in the pipe system in toilets should not exceed 5 curved pipes. Because if it exceeds, there is a chance where the contents that were flushed will stuck up in one of the pipes, thus creating a clogged toilet. To avoid clogging of toilets and better continuity of flow in flushing, it is better to not exceed 5 curved pipes in the pipe system of toilets. So the next application for fluid mechanics are dams. Dams were built for water supply, irrigation, flood control, navigation, water quality, sediment control, and energy. Most dramatic examples of fluid mechanics in action are hydroelectric dams. They are huge in size and equally impressive in power, for they can generate using completely renewable resource, which is water. The steel and concrete structure of hydroelectric dams holds back millions of tons of water from the river or other bodies of water. The water nearest the top has enormous potential energy. Hydroelectric power is generated by allowing controlled streams of this water to flow downward, collecting energy that is then transferred to powering turbines, which in turn creates electric power. Pascal's principle can be seen in the operation of any number of machines that represent variations on the idea of a hydraulic press. Among these is the hydraulic jack used to raise a car off the floor of an auto mechanics shop. Beneath the floor of the shop is a chamber containing a quantity of fluid, and at the either end of the chamber are 2 large cylinders side by side. Each cylinder holds a piston, and valves control flow between the 2 cylinders through the channel of fluid that connects them. In accordance with Pascal's principle, when one applies force by pressing the piston in one cylinder, which is the input cylinder, this yields a uniform pressure that causes output in the second cylinder, pushing up a piston that raises the car.
Created using Powtoon.